when we talk about organic compounds are divided in many categories, right? On the basis of whether it is open chain, whether it is cyclic, within cyclic, whether it is aromatic, whether it is aliphatic, okay, whether it is, if it is aromatic compound, whether it is benzene aromatic compound or non-benzene aromatic compound. So this is the categorization given here. Organic compounds first are divided in acyclic. Acyclic means non-cyclic. Non-cyclic means open chain, or cyclic. Acyclic, we don't have much categorization, but cyclic, we have again further two categorization: alicyclic or aromatic. Aromatic, we will be talking about, there are specific three conditions the compounds must meet. Okay, three conditions we will be talking about later for aromaticity. And these are non-aromatic compound. Alicyclic means non-aromatic compounds. For simplicity, when we say aromatic compound, these look like that these have benzene ring, for example, but not necessarily. That's why these aromatic compounds have further subdivision in benzenoid compounds, non-benzenoid compounds, and heterocyclic aromatic compounds. So when I say the alicyclic, it is open chain like this. When I say cyclic, then it is like this. And specifically here it is homocyclic or carbocyclic compound, means here all are just carbons. Homocyclic means only one type of elements in the cycle. Only one type of elements in the cycle. Then if we talk about heterocyclic compounds, again in non-aromatic we are talking about. Heterocyclic means in the cycle there are different types of elements, oxygen and carbon, two different types of elements are there in the cycle. That's why heterocyclic. Now we move to aromatic compounds. Within aromatic compounds we have benzenoid. Benzenoids are those ones which have benzene ring. Non-benzenoid, these do not have benzene ring. So if you see, both of these are not benzene rings, but still these are aromatic because we have some conditions. We will talk about three conditions. If they follow these conditions, these are aromatic. In the beginning, the name aromatic compound was taken just because they have some specific aroma, okay, scent emerging out of these compounds. So that's why these were given name aromatic compounds. But later on, we found that there are aromatics, similar compounds. They do not have smells, or the other compounds have a smell, but they are not aromatic. So, but the name has not been changed. Still, the name is same, aromatic, but it does not necessarily mean that they will have good smell.
Sir, do they include esters as well?
Yes. Okay. So the reason is again, we will be talking about, I will talk about it in detail when I talk about the three conditions the aromatic compounds must meet. Okay. But yes, we will be talking about esters. Okay. Then heterocyclic aromatic compounds. This one is aromatic compound, means it will follow those three conditions, but the elements here are carbon and nitrogen, different elements in the same cycle. That's why it is heterocyclic compound. This one.
Sir, can you please show the previous screen once again?
Yes.
Yes, sir, written.
This is something, most of the thing you already know: methane, ethane, propane. They have general formula of CnH2n plus 2. If these are attached to some other compound, then obviously one hydrogen will be removed and that particular electron will get attached with the other chain. So in that case, one hydrogen will be less if these are used as chain, side chain. So instead of CH4, it will become CH3. So CH4 is methane, But if methane is suppose attached to say CH2CH3 and it is attached here, then it will be attached as CH3, methyl group. If ethane is attached to something, obviously one hydrogen will be less, so C2H5 it will be ethyl group. So alkyl group, methane, methyl, ethane, ethyl, propane, propyl, butane, butyl, etc. Okay. So at the most maximum decile will be used in 11th and 12th standard. Methyl, ethyl, propyl, butyl, pentyl, hexyl, heptyl. Now the difference from 10th standard is that in 10th for 7 it is sept. Okay, so in most of the cases in 10th organic chemistry, for 7 carbons it is called sept, but in 11th 12th onwards now 7 is heptyl. Just do remember that you don't write septyl from 10th standard, it is heptyl. Okay, so heptyl or octane, 8 octane and 9 nonane. Okay, so octane for 8 electrons, sorry, 8 carbons, nonane for 9, okay, and decane for 10.
So could you please show the previous screen?
This one?
Yes, sir, just a minute.
So now we have to learn the names of alkanes in trioctane.
Yes, maximum trioctane if you are preparing for competitive examinations also. Okay, but normally
Okay.
questions do not appear for icosane or trioctane, but it is only decane.
Yes, sir, finished.
Now the very important part starts, and before I start it, there is a reminder that you must, as I said, there are certain patterns. If you learn right from now, if you keep revising, the organic chemistry is very easy. So make sure that you are attentive. Don't sit lethargically. Just be attentive. Most important part, because you will be using the same thing in 12th standard also. Okay. IUPAC naming, very easy thing, but it will be talked throughout organic chemistry in all the chapters, whether it is 2 chapters here or whether 4 chapters in 12th, everywhere. And there are certain rules which you need to remember. The rules, before I start the rules, there are certain structures which you should know, that if this appears, this will be called iso group. So what is the definition here? Whatever is written, for example, you have a compound like CH3, CH2, 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 CH3. But suppose on this carbon, there is one hydrogen less, and in that place you have another CH3. Then this particular structure is known as iso. It means in this compound, I have one iso group. Then, depending on how many total carbons are there, if I write it just like this, tell me whether it is alkene or alkyl group. Tell me whether this, whatever is shown on the screen, is alkane or alkyl, and why? Who will tell me? It can't be alkene, Samad. I'm asking only between alkane and alkyl.
I think
Aryaman,
it's alkyl.
just think about it, Aryaman. No, Arjun, yes. Pratham, yes. Kartike, reason also correct. Kartike, good. Ishwar, no, Ishwar, it is not following the formula. CnH2n plus 2. Okay, Savya, yes, your answer is correct. Yes, Arjun. The reason is Lakshya Tanu correct, because there is one carbon less, and moreover, you can see that there is one bond open. If one bond is open, it means it is connected to something else. It is alkyl group. Moreover, if you want to check, it is not CnH2n plus 2. Otherwise, it should be CnH2n plus 2 if it is alkane. But here, how many carbons? 3. How many hydrogens? 3 plus 3, 6 plus 1, 7. If it is alkane, then it should have been C3H3 to the 6 plus 2, 8. No, it has one hydrogen less. It means it is alkyl group. This is alkane. This is alkyl. One hydrogen less. So whenever you see open bond, that's a hint that it is alkyl. It cannot be alkane. Another one you can compare with CnH2n plus 2.
Sir,
Yes, any question here?
sir, I just wanted to ask, sir, if the if bond is open, so sir, it is alkyl only.
If bond is open, then it will be alkyl. It cannot be alkane.
Okay, sir.
Now we will say yes, it is iso group, but to name it, we will see now how many carbons are there. 1, 2, 3 carbons. And for 3, the alkyl group is propyl. This one. So we will name it as isopropyl. Remember the spelling of alkyl. It's not E afterwards. So don't write it like propyl. No, this E is not there. If you have understood this one, isopropyl, you can, first I will explain. You can write the name of the other one also. Suppose I write now as CH3, CH3, CH2, this one. Now you will apply the same logic. It has iso group. So you will write iso. But in the alkyl, how many total carbons are there? 4 carbons. So you will say butyl. If this group is attached to any other main chain, okay, any other main chain, this is connected in the side, then it will be named as isobutyl. Or maybe something else is connected, say here OH is there. I will say isobutyl alcohol.
If there's no open chain, then we just name it as butyl, right?
Yes, but the stand-alone existence of alkyl groups is not there. Okay, they do not exist stand-alone. They
Yes,
have
sir.
to get attached. But because we are just talking about it, that's why we are saying isopropyl. But they will certainly be connected to something.
Yes.
So can you please explain the structure of isobutyl alcohol once again?
Yes, yes. Okay. Arjun, I am coming to that. Okay, I'm coming to that. So how we do it? First, we say that the carbons structure is this one. 4 carbons in total. Okay, remember, I am not talking about IUPAC nomenclature based on numbering. That is certain rules. That's why I said in the beginning, before I start talking about the rules, I am talking about some structures where you need to remember these names. Okay, so based on the rules, there is another IUPAC naming convention, and that will be preferred. Instead of writing isobutyl alcohol, you will be writing it as per IUPAC nomenclature, which I will be explaining shortly. Okay.
Okay, sir.
What I am saying, Samad, here it is iso group. So I will write iso. Then I will say total how many carbons are there in this alkyl group. Alkyl group is from here because this is open bond. This whole is alkyl group. Here, how many carbons you have? 4. And for 4 carbons, you have butyl. For 4 carbons, butyl. So you will write it butyl iso. After that, you will write butyl. After that, if here it is connected to chlorine, you will write chloride. If here it is OH, you will write alcohol. Is that clear now?
Yes, sir.
Now the other one, which you need to remember. If this structure appears, and how the naming is done here, so try to understand. Here, the open bond, which makes it, this open bond makes it alkyl group. Okay. This is on which carbon? For that, you need to understand the concept of primary, secondary, and tertiary carbon. For that, I'm first explaining the definition. If you come across 1 degree carbon, which is also known as primary carbon, it means this carbon is attached to one or none other carbon. One or none other carbon. For example, if I have CH3, CH2, 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 CH3, this particular carbon is attached to only one carbon, this one. So because it is attached to only one carbon, this is 1 degree carbon. Now you must have guessed the condition for 2 degree carbon. 2 degree carbon will be that one which is attached to 2 other carbons. So this carbon is attached to 2 other carbons, so it will be 2 degree carbons. So degree means how many carbons it is attached with. But in 1 degree, there is one more thing, that even if it is attached to no other carbon, it will be 1 degree. For example, CH4. CH4 carbon is not attached to any other carbon. Even then it will be termed as 1 degree primary carbon, because this is the only carbon present. So this is 1 degree carbon. If it is attached to one more carbon, even then it will be 1. 2 carbons attached, 2 degree. Okay. So here the carbon which makes it the alkyl group, that is which has open bond, is 2 degree carbon, because that carbon is attached to 2 other carbons. So I'm repeating. The carbon which has open bond, that is the carbon which is making it alkyl group, is attached to 2 other carbons, means it is 2 degree carbon. 2 degree carbon is known as secondary carbon. 1 degree primary carbon, 2 degree secondary carbon. Secondary carbon. So from there we take the name sec. So this will be known as sec. And then we will see how many carbons are there total in this alkyl group. How many total carbons? 4. Butyl. So this alkyl group is sec butyl. Any confusion, any point not clear, let me know.
Please explain once again.
Which filter you have applied on your audio? Just let me know.
Sir, she is asking you to explain it once again.
Okay. What I am saying, first understand the definition of 1 degree, 2 degree, 3 degree carbons. So if I have written CH4, CH3, 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 CH2, CH3, CH3, CH2, CH, CH3, CH, CH3. Okay. Suppose I have these four compounds and I need to find out which carbon is primary carbon, which one is secondary carbon, which is tertiary carbon. So we are talking about the definitions of 1 degree, 2 degree, 3 degree, that is primary carbon, secondary carbon, and tertiary carbon. So 1 degree carbon will be that one which is not attached to any other carbon, or if it is attached to only one carbon. So this is 1 degree carbon because it is not attached to any other carbon. Remember, carbon, not hydrogen or any other element. Carbon attached to carbon only. Similarly, this carbon is attached to only one carbon, so it is primary. This carbon is also attached to only one carbon, primary. 1 degree. This carbon is attached to only one carbon, so 1 degree. But this carbon is attached to two other carbons. It means this carbon is 2 degree carbon or secondary carbon. Again, this one 1 degree because it is attached to only one carbon. Following same approach, 1 degree, 2 degree. But now this carbon is attached to 3 carbons. 1, 2, 3. It means this will be tertiary carbon, 3 degree carbon. Okay. Now this carbon is attached to only one carbon, 1 degree carbon. So this is the definition of primary, secondary, and tertiary carbons. Is this clear, everyone? If you are asked about 1 degree, 2 degree, 3 degree, and this is actually question appears.
Yes, sir.
You will be asked to find out which carbon is primary, secondary, or tertiary. Following that approach, we said that this alkyl group has open bond on this carbon. It means this carbon is making this particular alkane alkyl group. Otherwise, if there would have not been any open bond, this would have been CH2 in that case. One hydrogen has gone away, that's why this is open chain. So this carbon makes this whole as alkyl group now. We will see whether this carbon is primary, secondary, or tertiary. In this case, this carbon is attached to two other carbons through bonds. Okay, it means it is 2 degree carbon. 2 degree carbon is known as secondary carbon. So based on that, we will call it sec. Sec. Why sec? Because secondary carbon, the carbon which has open bond, which is making it alkyl group, is a secondary carbon. After that, we will have seen that how many total carbons are there here. 4 carbons are there. So for that, 4 carbons alkyl group is called butyl. So we will call it sec butyl. Normal butyl group would have been like this: CH3, CH2, CH2. If it is just butane, it would have been like this: CH3, CH2, CH2, CH3, butane. But if one hydrogen is less here, it will be butyl. So to differentiate that this one is butyl, we add here sec, that secondary carbon is making it butyl. Sec does not mean here second carbons. Sec means secondary. No, we can't, Kartike, we can't call it isopropyl. There is no such group. Isopropyl is exactly this group. Exactly this. So we will not call it isopropyl. It is sec butyl group. I would say if you just memorize that, if you see these type of structures, have a map in your mind, it is isopropyl, sec butyl. Okay. Now the other one, this one. Okay. Here I have already explained this one. this group is iso group, but total alkyl group is this one, which has 4 carbons. So that's why butyl. This is isobutyl. Okay, Devanshi. Next, this one has been given a separate specific, similar to the concept we have already talked about in sec-butyl. Okay, again a separate name. The carbon which has open bond is attached to how many other carbons?
So 3.
3. So it means it is 3-degree carbon, which makes it alkyl group. So we will write tert. Instead of sec, in previous case, we had written 2-degree, sec, 3-degree, tertiary. So tert. Okay, just 4 letters of that, tert. Then in this alkyl group, how many total carbons are there?
Sir, 9.
Carbons.
Oh, sorry.
Four.
Sir, 4.
4. Butyl. So in previous case, the carbon which made it alkyl group was secondary carbon. That's why sec-butyl. In this case, the carbon which makes it alkyl group is tertiary carbon. So that's why tert-butyl. So it will be good if you just memorize these type of structures. The moment you see, you can write it. It is tert-butyl. Now, it is likely that you will not use these until you get these written in your question paper, or you get these as choice. Because if you are asked about IUPAC nomenclature, most probably you will not be writing in this fashion, although this is correct. As per IUPAC nomenclature, this is acceptable name. But most probably you will be using the rules I will be talking about later. Now the last one. If you see this structure, this has been given a specific name, right? There is no rule about it. This is neopentyl. What is the difference? The difference is with the tert-butyl, right? It was tert-butyl. This is tert-butyl. Okay. On tert-butyl, on that carbon, you have one CH2 more. After that, you have open bond. So you have one CH2 extra. This CH2 is extra from tert-butyl. And this actually changes the nature altogether. Why it changes the nature altogether? The reason is, here the alkyl group initially was on 3-degree carbon. But now it is 1-degree alkyl group, because this carbon which has open bond, that carbon is 1-degree carbon. And this question is asked very frequently, whether it is tertiary alkyl group or secondary alkyl group or primary. It is primary. Don't think that it has this carbon. No, now this carbon is not playing any role in making it alkyl group. It does not have open bond. Open bond is on this carbon now, and this carbon is 1-degree. So neopentyl is 1-degree alkyl group. So if you see this structure, this is neopentyl. Why pentyl? Because 5 carbons are there. That's why pentyl. Draw these structures, and after the class also, just within 5 minutes, try to memorize and see whether tomorrow you are able to recall it or not. Now these are the rules. Obviously we can't finish it, we don't have that much time, but a few anyway I will be talking about today. These are the rules to name the compounds, organic compounds, so that throughout the word there is no confusion. Everybody is talking about the same name. What used to happen earlier, that Russians used to call a compound with different name, Americans with different name, okay, and Europe with different name. So that's why IUPAC naming means these are certain rules and are common everywhere in the world. So first of all, the longest carbon chain in the molecule is identified. To name the compound, so suppose I have written a compound as CH3, CH2, CHCl, CH2, CH, CH2, CH3, CH3. Now tell me in the chat box, which one is the longest chain? How many carbons are there in the longest chain? What is the longest chain? You can see number of carbons in longest chain you need to write in the chat box. Okay. Arjun correct, Pratham correct, Laksh no, Kartike no, Ariman correct, Ishwar no, Sabya yes, Lemuel no, Kavish yes, Devanshi no, Samad yes. Okay. The longest chain you have to find out, and that is the problem students face sometimes, and the mistake is there. The longest chain is this one, 7 carbons. Okay, 7 carbons. The longest chain, first point. If you make mistake in the first point, everything else will be wrong. So be cautious here. Okay. Yes, Shivani, correct. We will start numbering from left, but I will be talking about it in a few minutes if I have time. Okay. The numbering is done in such a way that the branched carbon atoms get the lowest possible numbers. So I'm just modifying it so to make it clear, so that the numbering, if this is, suppose this is the compound, then I can start numbering from anywhere, from left or right. I can say this one is 1, 2, 3 like this, or I can say 1, 2, 3 like this. But suppose I have a branch here, CH3. Longest chain is this one. Okay. So 1, 2, 3, 4, 5, 6 will be these carbons. But whether I need to start from left or from right, the numbering will start from that side, which side the branching is nearer. So this branching, if I start from here, 1, 2, 3, it is on third carbon. And if I start from left, 1, 2, 3, 4, no, 4 is not nearer, 3 is nearer. So it means this branch is near to right side. I will start numbering from right side, 1, 2, 3, 4, 5, 6. I will number the carbons of the main chain. What I am doing in second step, I am numbering the carbons of main chain. Okay. Then prefix alkyl groups to the name of the parent alkane with position. So what is the parent? Parent is the longest chain, main chain. What is that? That is hexane. 6 carbons means it is hexane, not hexene, hexane. Third step is that I need to prefix, means I need to write here prefix the alkyl groups attached, means here there is only one, CH3. It is methyl. So I will prefix it with its position, means where it is 3. So I will write 3 methyl. I will keep the first letter capital. First letter of the IUPAC name will be capital letter. So it will be 3 methyl hexane. 3 steps only we have talked about. There will be variations. So suppose instead of 1, you have 2 groups attached, 2 methyl groups. Suppose here also you have CH3 on second carbon. Now you have 2 methyl groups attached in the main chain. So main chain is still same, hexane. It is called root or parent chain or main chain. Remember, this is called either root or parent chain or also called sometimes main chain. Root, parent chain, main chain. It is same. But now I have two methyl groups, one at second and the other one on third carbon. So I will mention both positions there. 2, 3. I will say now 2, 3, but I won't say just methyl. There is a convention that I will mention how many are there. That is also I will mention. So I will write 2, 3 dimethyl. There are two such groups, methyl groups. How many methyl groups? 2. For that, dimethyl hexane. So the name will be 2, 3 hyphen dimethyl hexane. Now the rule, which is not written here, there will be no space here, no spaces except a few, except just I'm mentioning one here because that is probably we need to talk about in 11th. Except if it is carboxylic acid. So if I write it carboxylic and acid, then I will have a space in between carboxylic and acid. If it appears in the IUPAC name, then I will say carboxylic acid and a space will be there. Otherwise, no spaces. Second, if I have to use the numbers one after the other, there will always be comma in between. So I can say 2, 2, 3. If on 2 I have 2 methyl groups, for example, suppose here I have another methyl group on this CH3. Now on second carbon I have 2 methyl groups. So I will write 2, 2, 3. Total 3 methyl groups are there. On second I have 2 methyl groups. 2 methyl groups on second carbon. So I will write 2, 2, 3 because on third also I have a carbon. And then I will write a hyphen and try
Trimethyl hexane.
methyl hexane. Yes. Then there will always be a hyphen between number and alphabet. There will be a hyphen between all, or you can say between a numeric and literal values. So between 2 and 3 and T, there will be hyphen. Wherever it appears in the name, even in between if it appears, and it will, okay, we will talk about it. You can see here methyl hyphen 2 hyphen M. So between letter and digit here, between digit and letter here, always hyphen, between digit and letter hyphen.